Now we will calculate the potential due to this ring. We know that this is your ring and we have to calculate the potential at point P. Let this point P is at a distance Z. You can assume that this is at a distance Z. Let this is nothing but the distance R and this is nothing but the radius of that ring, capital R. So consider any point P which is along the axis of this ring. Now to calculate the potential due to this ring, assume that the charge is distributed uniformly on this ring. So we know that the charge is distributed uniformly, so you can use that your linear charge density, that is lambda, which is equals to your total charge upon total length. Then if I just consider this your total charge, or that is Q upon total length, that is 2 pi r, but that is also same for your that infinite small amount of charge dq and that small length also. So even you can just consider that is for your small length, let it is nothing but your dl. So I just consider a small part of that ring which is nothing but you can say dq. So let this is nothing but the part dq and this dq is distributed on this length dl. So let it is making some angle which is d phi. So according to that we know the potential which is dv, which is equal to dq upon 4 pi epsilon naught r. So obviously this r is the perpendicular, or that is nothing but the distance. So you can write it down that r according to Pythagoras theorem, that is a square root of r square plus z square. So just put this value which is dv dq upon this 4 pi epsilon naught square root of r square plus z square. That capital R is the radius of that your ring and z is the distance of this point P where you have to find the electric potential. So this is the potential due to this only small charge dq. Then this dq you can also write it down, which is your lambda into dl. So to find this dl, so even I can show it separately. So you can write down this dl, which is this r into this d theta. So this dl you have to write down as r into d theta. So further this will get simplified. You can write it down that dv is equals to your dq, and that dq is lambda r d theta upon same, that is 4 pi epsilon naught square root of r square plus z square. So that is lambda r d theta. So this is, you have to write it down. So then what I will do, I will just do the integration for that d theta. So this d theta is varying from 0 to 2 pi. So after simplifying it, so what you will get, so for example, so you can write it down now that dv, again that is lambda r, the integration you have to take from 0 to 2 pi. So obviously it will be 2 pi and again 4 pi epsilon naught in bracket r square plus z square. So again we know that this lambda r 2 pi, if you just do this, this total length is nothing but 2 pi r. So this total charge is q. So this dv is 4 pi epsilon naught square root of r square plus z square. So this is your total potential because of this your ring. So this you can write down or consider as a final expression. You now might vary that your value of your Z, and according to that you will get the condition for that potential. So if you assume that this Z is equals to 0, obviously that potential will be maximum, which is at the center. So this is your final expression for electric potential due to this ring.